Um, this is still practicing our GCF. So it says factor the following using the GCF method. So I want to sort of even break the instructions down a little bit. Please notice it's not asking you to just find the greatest common factor. Okay? It's saying to factor using the greatest common factor. So here's the difference. If it said find the GCF, you would just have one answer, right? You would just have something. Like you'd have 3x or whatever. That would be the GCF. But when it says factor, it means your answer is going to be in factored form. Remember, factors are things that are multiplied together. So it'll be something times something else. And it's really just rewriting this entire thing into factors. This is just one thing. It's just the GCF. But remember yesterday, in the last 2 days, when we talk about writing the leftover factors in parentheses? So when it says to factor, it means write the GCF and the leftovers in parentheses. Okay? The only way you just have one term for your answer is if it only said find the GCF, and then you would just have that one thing. So here's what we got. I'm going to do the first, we're going to talk about the first problem. It's not too hard. I'm going to do the second problem long and drawn out, and then I'm going to do the third problem and model for you how you could do that in your head. Okay, because remember, you want to get faster and better. You can still do the long method anytime you want, but you do want to work towards being able to be more quick about it. So for number one, if I'm looking at 18x and I'm looking for 12, looking at just the number parts first, 18 and 12, what's the biggest number that goes into both of those? 6. And do they have any x's in common? No. So then this is my GCF. It's going to go on the outside. And then I'm going to put the leftovers, quote unquote, in parentheses. So 18x, when I divide out 6, I'm left with 3x minus 2. Okay, and how could you check yourself here? What's that property called? Distributive, right? So distributive is where you multiply through. Factoring is when you divide through. So factoring is like reverse distributive property. So number 2, 21x cubed plus 35x squared. Here's the long method where you expand everything. Like 21 is 3 times 7, and then it has 3 x's. 35 is 5 times 7, and it has 2 x's. And you find what they have in common. They have a 7 in common, and they have 2 x's. And so then putting those back together, multiplying them back, your GCF is 7x squared. That's the most things that they have in common, the greatest. And then the leftovers go in parentheses. What's left over in the first term? 3x. And in the second term, 5. But now I'm going to walk through that problem now as if we hadn't done it like that, and as if I was just doing it quickly, like the quicker way. Okay, so since we already know what we're looking for. So here's how I would do it more quickly. Let me do this in a different color, see? I would look at the numbers, and I would say, okay, what's the biggest thing that goes into 21 and 35? It's 7, right? I would think about that for a while. I would write 7. And then I would look at the x's, and I would ask myself, what's the most x's that they both have? How many? 2. They both have 2. And so then I would put in parentheses. And now here's where I want to talk about thinking and remembering that this is like distributive property with division. I'm dividing a 7x squared out of each term. So if I look at this 21, what's 21 divided by 7? 3. And when I look at the x cubed, I'm dividing it by this x squared. What's x cubed divided by x squared? Just 1x. I just have that one left over. Okay? And then plus, what's 35 divided by 7? And what's x squared divided by x squared? 1. It's 1, right? Not 0. It's 1, and then times 1, you don't have to write, right? See how I got the same thing? I figure out what my GCF is first, and then imagine I'm dividing all the other terms, I'm dividing out the GCF. And that will give me the leftovers as well. So here's how that would look for number 3. I'm not going to do number 3 long. 15, 60, and 90. What did you come up with was the biggest number that goes into all of those? 15, right? Now, when the numbers get bigger like this, you might want to do a factor tree. Like you might be like, I can't do that in my head. That's actually a good candidate for at least the number parts, doing the number parts long. Like that's 3 times 5. 60 is 2 times 30, which is 2 times 15, which is 3 times 5. 90 is 2 times 45, which is 5 times 9, which is 3 times 3. And then look and see what they have in common here. They have a 5 in common. They have a 3 in common. And so 3 times 5 is 15. So now I'll do the rest in my head. Looking at the m's first, what's the most m's they all have? 2. So that's my GCF. And then looking at the n's, what's the most n's that they all have? 3, right? Because that one has 4, but those only have 3. So in common, they only have 3 n's. And then the leftovers go in parentheses. So thinking about division, I took 15 divided by 15 is 1, so I don't have to write that down. M cubed, dividing out 2 m's, how many m's do I have left? 1. N cubed divided by n cubed, they're all gone, so I have no n's left. And then minus comes from the problem. 60 dividing out 15 gives me 4. M squared dividing out m squared, no m's left. N to the 4 dividing out 3 n's leaves me 1. And then plus comes from the problem. 90 divided by 15 is 6. M squared dividing out m squared is just 1. There's none of those left. And then n cubed dividing out that n cubed, there's no n's left. Right? And I could always check myself with distributive property. So the lesson that we're doing today uses GCF again, but we're sort of leveling it up. So we're going to start a little bit slowly with numbers 1, 2, and 3, and then I'll show you how we'll use that skill in the actual lesson part. So number 1, 2, and 3 is just kind of getting us warmed up. It's still a GCF problem, 1, 2, and 3. But the GCF here works a little bit differently. The GCF here is a group of things in parentheses. So I want you to notice on number 1, we actually have 2 terms. We have this thing that's here and this thing that's here. Okay, and they're being subtracted. So thinking about that's 2 different groups, what do those groups have that's the same? The y? Well, not just the y plus 7, yes. So those parentheses around the y plus 7 make it a factor, okay? Because we have y plus 7 times the 3y. So they both have the y plus 7 that's the same. So I'm still going to use my GCF times leftovers form, but this time my GCF is a group of things. It's the y plus 7. This is my GCF right here. And then I make new parentheses, just like we did in the warm-up in the last couple of days, and I put the leftovers inside. In this first group, when I take out a y plus 7, I'm left with 3y. And in the second group, when I take out a y plus 7, I'm left with minus 4. And that's my answer. If I FOILed or did double distributive property on there, I'd get back the original problem's not quite written like that. Okay, you try 2 and 3, following that model. Okay, so for number 2, what did both of the groups have that was the same? Okay, good. n plus 3. So I write that down. That's their common factor. And then I new parentheses for leftovers. What's left over in the first one? 4m. And what's left over in the second group? Minus 7. Done. See? What did they have in common for number 3? N minus 4. Parentheses close, parentheses open, then what? 8n plus 5. Very good. Okay. So we feel comfortable with that. That's still GCF, I want you to understand. But this time the GCF was a group of things, not just one term. Right? So here's how we're going to use this for today's lesson. We are going to take this example problem. Okay. We're going to put it in, we're going to get it in, bless you, this form, so that we can then get it in this form. Okay. This y plus 7 times 3y minus 4, that is what we call factored form. The original problem is not factored form because of that minus in the middle. Factors just mean there's only something times something times something times something. There's not something plus something times something. Now it can have plus or minus inside the group, but not outside the group. Outside it always has to just be multiplication. And the reason why that's not what we have here is because I have pluses, 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 and not inside any groups, not inside any factors. So here's step 1. Step 1 is to group terms with common factors. So basically what that means is we're going to group these together, and we're going to group the second 2 together. So it's going to look like this. xy plus 3 plus 2x plus 6. With one special caveat. Even though I put parentheses there, this right here does not mean multiply. Like usually when we see parentheses next to each other, we know it means multiply, but in this case, I'm just using the parentheses to group stuff, not to multiply stuff. So be careful about that. The second step says to factor out the common factor in each group. Another way that you might want to reword that is GCF method on each group. Do the GCF method on each group separately. Do the GCF method on each group separately. And here's how that would look. In the first group, sorry, I forgot to put that y there originally. In the first group, what do they have in common? A y, so I write that down. There's their GCF. I write the leftovers in parentheses. When I divide y out of the first term, I'm left with x, plus, when I divide y out of the second term, I'm left with 3. Okay. So I GCF'd that first group. So now I'm going to GCF the second group. What do they have in common? 2. Okay. So don't forget that plus right there. So that's a plus 2 that they have in common. Their leftovers go in parentheses. X plus 3. Now you see how that worked? Now they have a common factor, just like our examples we did 1, 2, and 3 on top. So then the next step, it says factor the common factor from the expression. So we did GCF on that group, GCF on that group, and now we're going to do GCF on the whole thing. What's both groups' thing that they have in common? Right, x plus 3. And then what's their leftovers? Y plus 2. Okay, and if you FOILed or did double distributive on there, you'd end up with the original problem. So I want you to try number 1. And then we'll talk about it. Okay. So here's what's up. We group them together. Take the GCF of the first group, which is y, and x plus 8 is left over. GCF of the second group is plus 3, and x plus 8, very conveniently, is left over. Right? Okay. So now what do... Yes, it will, on purpose, for this. I won't give you any really tricky ones. And then here, what do they have in common? X plus 8. And in the first group, what's left over? Y plus 3. Okay. If you haven't tried number 2, do number 2. Okay. Oh, and I should... So we group them together. The first one had a B in common with an 8 plus 7 left over. The second one had an 8 in common with an 8 in common with an 8 plus 7 left over. And then that's what we get. All right. So again, sorry about not running the back and sort of faking you out that we were going to be done. But there's only a few examples on the back. So what we're doing, what was supposed to be copied onto the back of your worksheet is a problem where there's some minuses. And we just have to be a little bit careful. It's the same process. We just have to be a little careful with the signs. So let me write it big for you so you can see it. It's x squared plus 3x minus 2x minus 6. And step 1 stays the same. We're going to group the first two and group the second two. And take the GCF of the first one is x, that's right. So it's x times x plus 3. 2? What kind of 2? So minus 2 for the next one, but here's what I want to drive home. Remember I told you that factoring is like distributive property for division? Okay, so we're dividing out the GCF, and we said the GCF is negative 2. So if I take that first term and divide by negative 2, what's my answer? Positive or negative? It's positive, right? Because I have negative divided by negative. Okay. And then if I take the second term, the negative 6, and divide out by negative 2, what's that? Positive 3. So here's why I'm sort of bringing this to your attention. Notice in the original problem there was a minus here, but it got switched to plus because the GCF was a negative. Okay? And you can double check that by using distributive. When we take that negative 2 and distribute it back, we get negative 2x, like original, and negative 2 times 3 is what? Negative 6. Okay? So that's where you always want to check yourself at that step before you go further. Your other clue is if you did it wrong, you're not going to have this x plus 3 matching in both groups. So if you get something different, that's your first clue. You have to check your signs. Okay? And so then from here, it's easy. It's the same as we've been doing. What do they have in common? And then left over in the first group is x, and left over in the second group is 2. So try number 3. You can try 3 and 4, but we're going to talk about number 3 before we move on to 4 as a group. At least try 3. All right. If you're having trouble getting started, remember you're first just grouping these together. And then after that, you're not looking at everything all at once. You're looking at it one group at a time. So just look at this group and find what they have in common. Like look at the 6 and the 3. What's the biggest number that goes into both 6 and 3? 3. And then how many x's do they have in common? 1. So then you put the leftovers in parentheses. we had 6x squared. We took 6 divided by 3. We took 3 out, which is 2. We had 2 x's and we took 1 out. We got 1. Minus, we took 3x out of 3x. Where does that leave me? How does that simplify? To 1. That's right. To 1. And if you felt like you should have put nothing there, like let's say you put 0 there, and you checked yourself now, and you did distributive, you'd get 6x squared. That's it. But you need to get 6x squared minus 3x. So that's why that 1 is there. Okay. And then for the second group, minus. And what's their GCF? What's the GCF of 4x and 2? 2. And leftovers go in parentheses. So when I do negative 4x divided by negative 2, that gives me 2x. And then when I go to that second term, positive 2 divided by negative 2 is negative 1. And now they both have a 2x minus 1. So their GCF is 2x minus 1. And then open up new parentheses for the leftovers. This is 3x. And what's left over here is minus 2. So try number 4. And then we will be done, and I'll give you your practice worksheet. All right, let's sort of real quickly talk about if you're sort of losing sight of the big picture, remember what we're doing. We're finding the GCF of this group by itself and this group by itself. And the GCF is what we spent the last 2 days doing, where we broke it down long, found what they had in common, and wrote it down and wrote the leftovers. So don't forget, if you're having trouble getting started and you feel like you're just staring and staring and you don't know what to do, you can just do this. You can say, okay, 42 is 2 times 21, which is 3 times 7, and I have 2 m's. 18 is 2 times 9, which is 3 times 3, and I have 1 m. Find what they have in common. They have a 2 and a 3 and an m. And that's their GCF. So you would write down 6m. And then the leftovers in parentheses is left with 7m plus 3. Okay? So if you feel like now that we have this new stuff, you're sort of forgetting the old stuff, remember it all goes together. And then the second group, I'm not going to do long, I'll do in my head. I'm going to look at, I know it's going to be a minus. What do 35 and 15 have in common? What factor? 5. Do they have m's in common? Or how many m's do they have in common? None. So I'm not going to write an m, right? And then parentheses, if I take negative 5 out of negative 35, left with 7. And I still have the m. And I have 15, I divided out a negative 5, negative 3. Oh, sorry. Yeah, negative 3. Oh, this was negative right here, right? See, okay, look at this self-check I did. So I do this, right? And I'm like, wait a minute. This piece was supposed to match. So I do distributive property here, and I realize negative 5 times negative 3 is positive 15. That's not my mistake. So my mistake must be here, where I have the plus 3. So I look at the original problem. Oh yeah, that was a minus. So I need to change that to a minus right here, okay? And that's how you can sort of check yourself as you go. And then the final answer, they have 7m minus 3 in common, and 6m left over in the first group, and negative 5 left over in the second. All right?